So today's presentation is about milk handling safety for the home dairy. Please note that this presentation is not for commercial milk handlers. It is not for commercial dairies. It's not for commercial creameries. You may not sell milk without a license from your state regulatory agency, and that's going to depend on what state you're in. There will be different requirements for different states. Some states do not allow the sale of raw milk at all. Others will have requirements for raw milk sales. And then if you are selling pasteurized milk and milk products, you have to follow the pasteurized milk ordinance or your local state ordinance. But again, this is for your home use only. So some considerations we need to have when we're producing milk for ourselves. One of the big ones is drug residues, and we're going to go through each of these in more detail. Toxic plant compounds. So these are chemicals that we find naturally in certain plants that can be passed through the milk. Zoonotic disease and bacterial contamination. So this is potential disease risks that you could get from the milk. And then spoilage. Spoilage can affect human health, and it will also affect the taste of the milk. So the best way to prevent drug residues in milk is to pay attention to withdrawal times. Withdrawal time is the amount of time it takes for a medication that you give to your animal to be nearly undetectable or not detectable at quantities that could affect human health. And so with withdrawal times, it's really important to have a good relationship with a veterinarian. If you do not already have a veterinarian, I would talk to your local extension office. They can give you some referrals to local veterinarians that might have some experience with livestock, if not sheep and goats. We have a lot more veterinarians now with sheep and goat experience than we used to. If you have any questions, then go to the American Association of Small Ruminant Practitioners. Okay, we have another participant with sound issues. So your veterinarian is your best resource when it comes to calculating withdrawal times and preventing drug residues in your milk. The veterinarians are trained in pharmacochemistry, so they understand withdrawal times and how those should be calculated. So even if you're using an over-the-counter medication, it's a good idea to work with your veterinarian on withdrawal times. And one thing to note is, as of a few years ago, any antibiotics that are important for humans are not legal to use unless you have a veterinary prescription. And they have to be used by the label only if they're given in food or water. So this is just something to remember. And most of those are not antibiotics that you would use in a dairy animal that's lactating. They're not labeled for that use. And so some important steps to avoiding drug residues in your milk. The big one is label usage. So if you're using any over-the-counter product, you need to follow the label directions exactly, including the milk withdrawal period. That will all be printed on the label. You want to make sure you weigh the animal to make sure you're giving the correct dose. Because if you're giving more than what the label says, then you extend your withdrawal period that you need. So you need to make sure you have an exact weight for that animal. Unfortunately, we don't have a lot of medications that we can use in this way if we're working with goats or dairy sheep. There are very, very few medications that are actually labeled for dairy goats or dairy sheep that are in milk. So most of the time, we're going to be stuck with extra label usage. This is legal as long as it's prescribed by a veterinarian. But again, this is why it's important to have that veterinary client-patient relationship. The veterinarian must prescribe it, and they must calculate a withdrawal time if you're using any drug extra label. So extra label is using a drug that's either not labeled for the species, not labeled for the particular age group, or the particular usage that you're using. So it could be an increased dose. It could be something that's labeled for a younger animal that you're using on an animal in milk. It could be something that's labeled for dairy cows that you're using in dairy goats. or dairy sheep. So there are a number of different reasons why you would have extra label usage. But any usage that is not according to the label is extra label, and that requires a veterinary prescription. So we're going to go through calculating a withdrawal time. So we're just going to assume that we have a label use, or we have a prescription from a veterinarian that tells us that this is the withdrawal time for this medication. So let's assume that we're administering a medication tomorrow, April 3rd at 8 a.m., and that medication has a 72-hour withdrawal period. When is it safe to use the milk? You can type your answers in the chat box. There's a little hint on that calendar on the side. So milk produced after 8 a.m. on April 6th is safe to use. The key is produced. So if the goat was milked at 8 p.m. on April 5th, you can't go on April 6th at 8 a.m., milk the goat and use that milk. No, you need to milk that goat out, and then the next milking, the milk will be safe to use. Does that make sense? Withdrawal times are really important when it comes to preventing drug residues in our milk. So the next subject is toxic plant compounds. And so we have a couple of plants that we're going to be taking a look at. But toxic plant compounds are chemicals in plants. These are natural chemicals that can potentially be found in the milk of animals that consume that plant. There are actually a lot of plant compounds that can be found in milk. But most of them are either harmless or maybe they cause a bad odor or something like that. So an example is the wild onion that's in the picture here. Bitterweed is another example. So some of these chemicals will get into the milk and they will cause taste and odor issues. There are some that will actually cause liver damage, but they're not likely to be in milk in that quantity unless you're already seeing significant impairment of the animal itself. And so there's one plant compound that causes the greatest danger to people, and that's a compound called trimetol. It is a type of alcohol, and it's found in white snake root and Rayless goldenrod. And so we'll go through those two plants. So white snake root is the one that's going to be of concern to most of us. It's found throughout the eastern United States, from the East Coast through Texas. It's very, very common in the Ohio Valley area. So those of us who are in Indiana, Kentucky, or surrounding states, it's a very common plant. You usually find it at the edges of woods. So it likes kind of that dappled shade. It usually blooms in September. And so trimetol is highly toxic to both livestock and humans. It causes a syndrome called Trimble's in cattle and other livestock. And so usually this is not something that kills instantly. It's cumulative dosage that is going to kill your livestock if your livestock are eating it. Now, normally livestock don't really want to eat white snake root. It doesn't taste very good. But if you have a drought year, if there's not a lot of other forage, and this is green, and then it may be attractive to your goats. And there are other similar plants that are perfectly edible to your goats because it's related to your daisies and your asters. And so those are perfectly safe for goats. And so goats that are familiar with daisies and asters may see a familiar looking plant and not realize that it's toxic. And so this causes the syndrome called milk sickness, which is what killed Abraham Lincoln's mother. So it was this plant that was responsible for the death of Abraham Lincoln's mother. So Rayless goldenrod has the same chemical in it, but it's not of concern to those of us in the Midwest or in the southeastern United States. It is a problem for those that are in the desert Southwest, from Texas to Arizona, in northern Mexico. And so it has the same toxin. And for both of these plants, both the green and the dry plant material contain the toxin. So what are we going to do about it? We want to learn the characteristics of these plants so that we can recognize them on site. So use some field guides, learn what the toxic plants are in your areas. In a couple of weeks, we will have a presentation on toxic plants. And so if you join that presentation, that can help. But one thing that's really important if we have pastured dairy animals is we want to make sure that we do pasture walks regularly and eliminate toxic plants from our pastures. If we know we have an area where a lot of white snakeroot grows, you might consider fencing it off so that animals can't access it. So this might be something like a hedgerow where you will have white snakeroot that will grow pretty thick in that area where you have partial shade. Those are areas that you might consider fencing off to keep the goats or sheep or other animals out of those areas. If you're really concerned about toxic plants causing problems with your milk, dry lot the animals that you're using for milk consumption. So take your dairy animals that you're using for the house milk, put them in a dry lot and provide all their food. That's the way that you can totally prevent contamination from these toxic plant compounds. But really the big one when it comes to milk safety is zoonotic disease. Zoonotic diseases are diseases that can be spread from animals to humans and vice versa. And when we're looking at milk safety, we're looking specifically at those diseases that can be spread either through the milk of the animal or through contamination of that milk on the dairy farm or in your dairy processing area. So we have a lot of milk-borne illnesses. Just a few of them are actually spread from the animal directly into the milk through their body. So the main organisms that are shed into the milk by an infected animal would be brucellosis, and this is the bovine form of brucellosis, tuberculosis, again, bovine tuberculosis, listeria, Staphylococcus aureus through mastitis, and Johne's disease. Now, a note here, Johne's disease is not proven to cause disease in people, but it has been found in some Crohn's patients, and it's a very opportunistic organism. So the jury's still out on whether or not that's a major human health risk, but it is something to consider. So this is a fairly short list of illnesses that are caused by being directly shed from the animal to the milk. However, there's a much longer list of contaminants of milk. And a lot of these will come from your barn environment. Salmonella, E. coli, Listeria, the Campylobacter, coliforms. All of those are very common organisms that you will find in the barn. A lot of these are fecal bacteria. Some of them are bacteria that you might find in feed that's been wet and sitting out. But they're very, very common in the environment. And a lot of these can be deadly. So you want to be really careful when you're handling your milk to prevent contamination. So with the diseases that spread from animals to people, or from animals directly into the milk, we can test for some of them. And that can help give us some peace of mind and help recognize that the animals that we're using in our dairy are not carriers of brucellosis, tuberculosis, or Johne's. So those are the three that we can test for. So they can help you with a general assessment of herd health. Now, most of us are probably in TB and brucellosis-free states. In that case, unless we know that our animals have been in an area where there could be tuberculosis or brucellosis, we're probably okay on that front. But it's still not a bad idea to test animals that you're using for home milk production anyway. But one big benefit, kind of a side benefit to testing your animals, is more people are becoming aware of disease in animals. And so having a tested, clean herd or flock can be really important in the value and the sales of your animals. And so if you test for these and other diseases, it can improve the value of your livestock. So yes, Q fever, that would be another one. I did not find a reference of it passing directly into the milk, but Q fever is an issue going from the animal to the person handling the animal. So that's transmitted it, directly from the animal to the human. And so a lot of times Q fever will be transmitted in birthing fluids. It could potentially be transmitted in milk, but it's more likely to be transmitted through handling the animals in general. So that's another good one to test for. I was focusing primarily on the diseases that are passed through the milk, not necessarily on diseases that can be passed from the animals to the people, but that is a very good point. There are other diseases that we want to consider just when we're handling our animals. And so if you're disease testing your animals, okay, so yes, Q fever can potentially be spread through milk. It can be spread through any bodily fluid, and birthing fluids are the most risky, but potentially through milk, yes. So brucellosis and Q fever both can be performed at veterinary diagnostic laboratories, primarily at state universities. In this case, your veterinarian will have to submit the sample. Tuberculosis is a test that's performed by your veterinarian. It's just like a human tuberculosis test. They're going to inject the tuberculin between the layers of the skin and then come back with 48 to 72 hours later to check for a reaction. If they see a reaction, then they have to contact the state vet, and then they'll do a confirmation test. But typically they're going to inject the tuberculin in the skin under the tail, if we're talking about sheep or goats. Johne's has a blood test. It's going to be most accurate in your older animals because it takes a while to have enough of a titer of Johne's or enough of the infectious material in there for it to be able to detect Johne's in the blood test. And so the blood samples can be collected by either the herd owner or a veterinarian. And there are private and state veterinary diagnostic laboratories that will test for Johne's. Because Johne's is not a state-regulated disease like brucellosis and tuberculosis, that's why the private labs can do this one. Brucellosis is a state-regulated test, and that's why it requires that it go through a state lab. Mastitis can be a major source of contamination of milk. To begin with, you really don't want to be drinking milk that has, from an animal that has mastitis. You're going to have bacterial shedding into the milk of the mastitis organism, but your milk's just not going to taste good. Because you have the inflammation there, you're going to have a lot of serum going into the milk, and so that's going to give it a salty flavor. There's some different tests out there for mastitis. The easiest, cheapest one is the California mastitis test. And so that's one where you have some different plates where you put the milk from each half of the udder or each quarter of the udder, depending on what species you're testing, into the plates and add the reagent. And then you'll be able to tell pretty quickly whether or not the animal is reacting or not to the test. It's not 100% with goats, but it does at least give you a baseline. An easier or a more sensitive way of testing would be to send some milk to a laboratory for somatic cell counts. A high somatic cell count usually indicates mastitis, and you can have a milk culture done if you suspect mastitis, maybe subclinical mastitis. If you have a hard udder, the animal's just not milking down properly, then sending it to a lab for a milk culture is a good idea. Fecal contamination is really the big one. A lot of us have milking areas that are not exactly clean. We may do our best, but some people have milking areas with dirt floors. You don't have washable walls. It's not set up like a commercial dairy. And so you have dust that can carry fecal bacteria in the air. Another source is on the animal itself. So the hair, the mammary system, the feet of the animal will all carry fecal bacteria. So it's really easy for fecal bacteria to get into your milk, particularly if you're hand milking the animal. And so if we just look at this goat, I mean, the udder's fairly clean, But if we look at it, we can see there's definitely opportunity for fecal contamination. She's been walking through a muddy area, so there's probably all kinds of fecal bacteria on her feet. The tail end is right above the udder, so that's an opportunity for fecal contamination. Who knows what she's been laying in, so what's on her hair? So we really need to consider fecal contamination when we're thinking about milk safety. So when we're milking, we want to make sure things are as sanitary as possible to reduce fecal contamination. So we want to make sure the udder is clipped and clean. So we're going to clip the hair off. We're going to sanitize the udder. And we want to make sure that our milking equipment is thoroughly sanitized, whether we're talking about a milk bucket or whether we're talking about a milking machine. And while we're milking, we want to make sure that we keep the feet out of the milk bucket. If feet get into your milk bucket, please dump the milk. That's not going to be safe to drink. You'll have all kinds of bacterial contamination of your milk. And then if you're using a milking machine, be careful about the claws and where they go, because that's the entrance to the milk that's in that machine. And so make sure that those claws are sanitized. Make sure that you're keeping them up and out of the dirt, out of the soil, so you're not introducing any bacteria to your milking machine. So we have about a 5-minute video that I recorded this week. I apologize in advance for the quality of the video, but hopefully we can get something out of it. The first step to ensuring a sanitary milking procedure is to clean the udder. And to clean the udder properly, it needs to be clipped hair. I'm starting at the top of the rear udder and removing the hair from the udder, number 40 blade. It's surgical. And the blade is going against the grain of the hair, so we get as much hair off the ear as possible. So it's much easier to clean the ear. Okay, so getting the udder thoroughly clipped. So I usually start with the rear udder. Some goats are more comfortable starting with the fore udder. When you clip the fore udder, you actually want to clip about 3 or 4 inches in front of the udder. Provide a clean space without hair, so you have less hair falling into the skull. Okay, so the fore udder sometimes is a little bit more comfortable for the goats to start with, especially if you have a yearling that's new to clipping. Now the udder is clipped, we're going to brush the hair off the udder and the surrounding area. Hair falling into the milk introduces bacterial contamination to the milk. So anytime you milk, it's a good idea to brush the belly to reduce the amount of loose hair that could potentially fall into the milk. Okay, so now we speed up the brushing procedure. Now we're going to sanitize the udder. After brushing off the loose hair, it's time to sanitize the udder. I'm using clean paper towels and a dilute solution of bleach. Okay, so using clean paper towels. Each half of the udder. Start with a teat. And then sanitize up the half of the udder. After the udder is sanitized, you want to dry each teat. Water dripping into your bucket is a great way to introduce bacteria to your milk. Now that the udder has been sanitized, I'm going to take a squirt of milk from each teat. I'm putting it onto my paper towel so I can check for any lumps or any kinds of mastitis. So there's a little dirt from her feet there, but overall we can see that the paper towel is clean, other than being wet. Now I will take a clean and sanitized stainless steel bucket that I have kept covered. We'll remove the cover and gently begin milking the goat, being careful not to allow her foot into the bucket. Okay, so sanitizing, I like to use a dilute Clorox or kind of bleach solution with some dish soap in it. You can get commercial sanitizers, your pre-dips or things that you can use. The key is you want something that's antibacterial. It doesn't, as long as it is going to kill most of your bacteria that are on the surface, that's what'll work. Now that I've milked, I'm going to cover the milk again until I can get it inside to strain it. Okay, so to answer some of the questions that came up, having lambs or kids on does not necessarily increase the potential for bacterial contamination. You're stripping the teat first, and so you should eliminate anything that's in the teat itself. So you shouldn't have too many issues with lambs or kids that are nursing. So after we milk our animals, we want to filter that milk, because even if we used fairly clean procedures, even if we brushed the animal first, had a cleanly clipped udder, sanitized the udder, there's still stuff that gets into that milk. And so we're going to take a look at what we see in the next video. But what filtering will do, so it's going to remove any hair, dead skin cells, dirt, and debris from the milk. It will reduce bacterial contamination of the milk that comes from these sources, and it'll improve the milk quality because you're removing these contaminants, and these contaminants hold bacteria. But what it does not do is the filters that we use for milk are not small enough to remove bacteria that are apart from these particles. So it will get these larger particles like cells, but if there are loose bacteria that are already in the milk, it's not going to remove those. Filtering is not going to remove the harmful plant compounds that might be in the milk. And it does not ensure that your milk is safe to drink. So just because you filtered it doesn't mean it's safe. So we have another short video. Covered milk that we brought in from our milking. My hands, that's coming. We're going to use a milk filter. Milk filter like this can be just from small stores such as Jeff. Ensure that our milk is dry. So you can buy these milk filters are not expensive. I think you can get the entire setup for probably less than $20. Filter papers can be purchased anywhere where you may use a milk filter. You really do want these. And place it onto our filter jar. This can be any jar that has a mouth of the right size for. We'll slowly pour milk to the filter. You need to do this in stages to fill the filter. So you really do want to use an actual filter paper. You don't want to use a coffee filter for this. These filter papers are designed for milk. And the milk will flow a lot faster through those than through a coffee filter.
If your filter jar is not large enough to hold all of them, we transfer them. While plastic is not the ideal material, it can work for temporary storage until you're pasteurizing.
Cheesecloth has too big of openings, so you don't want to use that for filtering. That's why we use the filter paper, because it's small openings, but it should be able to filter quickly.
Speed chills with fecal experiment, 2 hours. Use an ice water. Place your container of the ice water pack. Stir frequently.
The reason you want to stir is so that your milk temperature can be even.
You may want to change your filter paper. Move milk to another. Filter papers can be clogged with air, cells.
You don't want to use paper towels to strain because they're just not going to hold up to this amount of milk going through them. You're really best off using the filter papers that are designed for straining milk.
Even washing the goat, I'm trying to go milk, still here.
We're going to take a close look at this filter afterwards. So the filters actually do capture a lot, and we have a photo that we'll take a close-up look at in a slide following this video.
Now that all the milk is filtered, we can go ahead and pour it in our holding. And we'll take a look at what's been filtered out. So here we have some flecks of blood, some blood clots, some hair, some dirt. So you can see how all of this could affect milk quality. All of this can hold bacteria, and that bacteria can move into the milk, have contamination of the milk.
Okay, so here we can take a close look at these two filters. So the first filter that we used is the one on the bottom that has the hair in it. And so that's from kind of the foam of the milk, what's in the upper part of the milk. So the hair tends to stick up in the foam, and in the upper part of the milk, it tends to float. The one on top is the one from the second pouring, where you got the bottom of the bucket. So here you have everything that kind of sunk to the bottom of the milk. Blood clots are not unusual in does that are newly fresh. And these does are the doe that I milked for this. She's about 3 weeks fresh, and this is the first time that I've taken her kids off of her and I had her fully uddered. So that can be from some capillaries bursting when they get full for the first time. So it's not uncommon. It doesn't mean they have mastitis. But now if you have a lot of blood in the milk, then that may be more reason to be concerned. But in this case, I'm not concerned about a few blood clots because that's fairly normal the first time they're uddered. But if you see any clumps, things that look like white cells, that's when I'd be a little bit more concerned. But because even with a sanitary milking procedure, you still end up with stuff in the milk. I really like to pasteurize the milk that I'm using. So what pasteurization is it's a combination of time and temperature that's needed to kill most pathogenic organisms. It's not going to kill all the microorganisms in the milk, but it will kill the vast majority of the pathogenic microorganisms. And so it does not denature or remove, it does not denature the milk, it does not denature the harmful compounds that are in milk or remove them if they're the plant compounds. So if you have white snake root in your pasture, it's not going to denature that compound. So it's still, the milk is still toxic if they've consumed white snake root. You can pasteurize at home using a pot on the stovetop, which that's the most difficult method because it's really hard to maintain temperature control. You can buy a small scale pasteurizer through most farm supply catalogs, or you can do what I do and use an electric multi-cooker. It's cheaper than your pasteurizer that you can buy through the catalogs, and to me, it's actually easier to use. And so when we're pasteurizing, there are different temperature and different time levels. So for vat pasteurization, which is what most small-scale cheese producers use, it's 145 degrees Fahrenheit for 30 minutes. As your temperature increases, the time required to pasteurize decreases. The others are considered high-temperature, short-time pasteurization, and that's usually done through, on a commercial scale, that would be done through a tubing system that heats up the milk very quickly, so flash pasteurization. But since we don't have access to that kind of equipment, the low temperature, long time is what I recommend.
Now that our milk is strained, we're going to demonstrate pasteurization. Pasteurization is a combination of time and temperature that kills the majority of the infectious pathogenic microorganisms that are found in a product. For milk, there are different time and temperature combinations that you can use. The one that I'm demonstrating today is low temperature vat pasteurization. This requires a temperature of 145 degrees Fahrenheit held for 30 minutes. For this, I'm going to use my Instant Pot Ultra. You can use any electric multi-cooker that has a custom setting available where you can set the temperature exactly. You could also do this on the stovetop, but it's much more difficult to control temperature on the stovetop. Before we begin pasteurization, we want to ensure that we have a thermometer that reads accurately. The easiest way to calibrate the thermometer is the ice water bath test. So we have a container of ice water that we've stirred. You have the ice in the water for at least 30 seconds. And this should be at a temperature of 32 degrees. Put your thermometer in 2 inches down. You want to continually move it. It'll take a few seconds for it to be able to read the proper temperature. So we'll add our milk to the liner, our Instant Pot liner, or other electric multi-cooker liner. The beauty of these electric multi-cookers is with the liner, you can ensure that you can remove your milk and you can put it in an ice water bath when you're finished pasteurizing to be able to chill it down to the proper temperature again. We'll put the lid on even though we're not going to use pressure. We'll get the best results if we keep the lid on. We can take it off from time to time to check temperature, to ensure that we reach the correct temperatures. On this particular pot, I'm going to use the ultra setting. We'll just leave the time as it is because it will take a couple of hours to be able to get the milk to temperature and hold it at temperature. And so we're going to go to custom temperature setting. to set the temperature a little bit higher than our goal temperature just to ensure that we have complete pasteurization. So I'm going to set it at 150. Our target temperature is 145. Delay is off, keep warm is off. And we're going to press, no pressure, and then we're going to press start. So you'll see it preheat, and you will see when it reaches the temperature, the target temperature. Well, first, the shell will reach the temperature, and then from time to time, we'll use our thermometer, and we will check the milk temperature. We'll make a note of when it reaches 145 degrees Fahrenheit, and then we will continue to hold it at that temperature until pasteurization is complete. So our pot has come to temperature. We'll take the top off, use a non-porous spoon to stir the milk, and we'll check the temperature of the milk. We'll replace the top and then let it continue to heat. Check the temperature. We're getting close to our target temperature. Our milk is at temperature. We're going to let it hold for 30 minutes. Our milk is pasteurized. It's been at temperature for the requisite amount of time. So we're going to go ahead and double check our temperature. Yes, it's above our minimum. So we can turn the cooking off. Stir one last time and move it to a water bath. An ice water bath. This way we can chill quickly. We'll continue to stir occasionally in the ice water bath until we get the milk cool, or we can return it to a glass container or use it for making cheese or yogurt or anything else we use for it for dairy.
Okay, so a couple of notes about that. I used the lid, but I didn't use pressure. The reason you want to use a lid if you're using an electric multi-cooker is because the milk will heat evenly if the lid is on. It will not heat evenly if the milk is off. And so even though I stirred it every once in a while, it probably would have been fine not stirred, simply because the lid was on. If you get one of these home pasteurizers that are sold through the catalogs, they actually have a steam jacket. And so you put water in, they heat the water up, and then they heat the milk up through the hot water. And then when they're ready to cool off, you put in cold water. You just run cold water through the jacket, and it'll chill and it will cool it. So if I'm using the electric multi-cooker, then I just take the liner out and just set the entire thing in a vat of ice water or a pot of ice water. if you are working on the stovetop, you would have to use the pot of ice water as well to chill it. But I don't really recommend the stovetop if you have other options. But if you're short on cash, the stovetop is an option. So why is pasteurization important? I've said it before and I'll say it again. It kills most of your pathogenic or infectious microorganisms that are found in the milk, which in turn reduces the likelihood of transmission of zoonotic disease through the milk. And so a lot of these things that are found as contaminants, your salmonella, your E. coli, all of those are killed by pasteurization. But it also impacts milk quality, because when you have bacteria in the milk, even if they're not pathogenic bacteria, a lot of these bacteria are going to affect your milk quality because they're going to break down the fatty acids in the milk, and this is what gives the milk a goaty flavor if you have goat milk. And so when these microorganisms start to break down this milk, your milk's going to go bad a lot faster. So pasteurized milk is going to keep longer in your fridge than raw milk will. So when you store your milk, you do want to use a non-porous container such as glass or stainless steel. These are not going to hold bacteria like plastic will, and it's easy. They can hold a higher temperature. They can stand a higher temperature, so you can sanitize them or sterilize them. You can't do that with plastic. You can use plastic for temporary storage, raw milk that you're going to be pasteurizing anyway, but I wouldn't use it for milk that you're going to store for any length of time. And if you are going to use plastic, make sure it's food grade plastic. And like any food that's subject to bacterial contamination, you need to store milk at 40 degrees Fahrenheit or below, and you want to bring it to that temperature within 2 hours. And while most milk is, most animals are not going to put disease into the milk or put bacteria into the milk, if bacteria gets in the milk, it grows really well because milk is designed to feed the young, and so it's very nutrient rich. So it makes just a very nutrient rich area for bacteria to grow, and so bacteria love to grow in milk. So any bacteria in milk are going to thrive. And so typically you're going to have a shelf life of 1 to 2 weeks with your pasteurized milk. Probably closer to 2 weeks if you pasteurize it. Raw milk tends to be closer to 1 week before you start to get some funky odors and flavors. But now it does depend on the individual producer and their practices, but typically you get a little bit longer shelf life with pasteurized milk than with raw milk. This list of resources is in that Google Drive folder, so you can go in there and click on these links, and it gets you a little bit more detail on some of the things we've talked about today. Do you have any questions that you can type them into the chat box. I will be posting this recording to YouTube tomorrow. So you can share the recording with anyone in your 4-H club or anyone else that you think might benefit from this information. So I'll go ahead and end the recording.